Hello formal geometry students and welcome back. This is section 5.3 and 5.5 which is on triangle inequalities. So first off to start we got a lot of theorems, so pause if you need to write this all down. The first theorem is theorem 5.8 which says that the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. Now all that means is that if I have a triangle, so this is my triangle, with angles, call this, remember that the exterior angle is an angle like right here, this is an exterior angle, call it A. So angle A is our exterior angle, and our interior angle will be angle 1 and angle 2. So this just says that, based on this theorem, angle A is greater than angle 1, or angle A is greater than angle 2. So it's gotta be bigger than both of those. Because remember, by another theorem that we had last semester, angle A is equal to angle 1 plus angle 2. So it's gotta be bigger than both of those. Next is 5.9, or theorem 5.9, which says if one side of a triangle is longer than another side, then the angle opposite the longer side is bigger than the angle opposite the shorter side. Now, let's break that one down. Got a triangle. This is our triangle. I'm going to quickly label the sides A, B, C. So, side AB, this side right here, is clearly the shorter side compared to side AC. By this theorem, that means that the angle opposite the longer side, side AC, this angle right here, which is angle B, is bigger than the angle opposite the shorter side. So the angle opposite this shorter side is angle C, which is right there. So those angle C would be shorter than angle B because it is across from the shorter side. That goes back to some ratios that we'll learn later on as well. Next is theorem 5.10, which says if one angle of a triangle is bigger than another angle of the triangle, then the side opposite the bigger angle is longer than the side opposite the smaller angle. So that's just pretty much the same as 5.9, but the other way around. So 5.9 says the sides relate to the angles. Theorem 5.10 says the angles relate to the sides. So let's do a couple examples. This one says using the exterior angle inequality theorem to list all of the angles to satisfy the stated condition. So we want to list all of the angles that measure less than angle 4. Angle 4 is right here. Now we don't know the measure of angle 4, but we know it is an exterior angle on this triangle right here. Oh. This triangle. Which means by the exterior angle theorem, which was theorem 5.8, that means that angle 1 and angle 2 are less than angle 4. We don't really know much about the rest of them. We could try to assume based on appearances, but we don't know for sure. Now let's look at angle 7. Let me erase this. Okay, and number 2 says measures greater than angle 7. So we need to list all of the angles that are greater than angle 7. Angle 7 is in this lime green triangle here. So if we look at where we have some exterior angles, we've got an exterior angle here, an exterior angle here, and here. 4 is not one of the exterior angles because you have to try to visualize this triangle as an extension. So if I extend these lines out, the exterior angles are going to be these ones right here. So, based on that, I've highlighted all of those angles that are exterior angles. Now, I just need to identify if 7 is a remote interior angle compared to those ones. So if I look at angle 3, the two angles opposite angle 3 are 7 and 8. So 3 is 1. Next, let's look at angle 5. Angle 5 is right here. Two opposite angles of that are 7 and 8 again. So angle 5 is 1. And last is angle 9. Angle 9, the two opposite angles of that one are 7 and 6. So angle 7. Or not 7. Angle 9. Ooh, 9 goes there. Those are all greater than angle 7. Great. Next, let's do angle, or measure of angle 2. Find all the angles that are greater than the measure of angle 2. Angle 2 is right there. So let's highlight this triangle that angle 2 is in. And now let's identify our exterior angles that we'll look at. So angle 4 is 1, and angle 6 is 1. But that's the only two I see. Angle 7 would not be 1 because it is not an extension of this line or that line. So now let's look at angle 4 and angle 6. Those are our two exterior angles. So I just need to see if angle 4 is an exterior angle with the two opposite angles of angle 2 and angle 1. It looks like it is. So angle 4 would be 1. And based on that same information, angle 6 is also 1. Okay, erase it. Next and last one on this page. Measures less than the measure of angle 9. So angle 9 is right here. This one is an exterior angle that lies on this triangle right here. If I could draw, I can't draw. This triangle. So 9 is our exterior angle. So let's look at which two angles are the remote interior angles. It looks like angle 7 is 1 and angle 6 is 1. So those are less than angle 9 by that theorem. So angle 7 and angle 6 are two angles. Okay, now we'll move on to 5 and 6. List the angles and sides of each triangle in order from smallest to largest. So let's look at number 5 and list the sides first because it gives us all of those. So I've been listing all of the sides from smallest to largest. This is easy because it gives us all the measures. Smallest side is this side BC because it is 1.7. You don't have to write it below. The next one would be AB because it is 2.8. And then the last one would be AC because it's 3.1. Now remember, we have the theorems 5.9 and 5.10, I believe, which state that the angles measure corresponding with the side. So if this is the smallest side, then the angle opposite this side, so the angle opposite this side is also the smallest angle. So angles from smallest to largest, angle A would be the smallest one because it is across from the smallest side. Same with, this is our medium side, and the angle across from our medium side is angle C. So angle C would be next. And then angle B would be the largest angle. We don't even need to know the measures of the angles to know that those are, that's the order. Okay, number 6, this one's trickier. It doesn't give us the measures of the sides, but this one gives us the measures of angles. So we've got 46, 87, and K, which we don't know. But we know that they all need to add up to 180 degrees. So really quick, let me plug that in my calculator so I can figure out what the measure of angle K is by doing 180 minus 87 minus 46. So angle K is 47 degrees. So in this one, I'm going to list my angles first because we have those. My smallest angle is angle J. It is 46 degrees. My next smallest angle is angle K at 47 degrees. And then my largest angle is angle L, and it is 87 degrees. Okay, now we'll do the sides. So, smallest to largest, take my smallest angle and I'm going to go directly across through the triangle to find the opposite side. My opposite side is LK. So LK is my smallest side because it is opposite my smallest angle. Same with my medium side. We'll go from my angle K, which was my second smallest, or second largest, however you want to look at that. It was 47 and it was in the middle. So my middle side is side JL. It is across from angle K. And my longest side is across from my largest angle, which is side JK. Okay, so we're moving on to the next set of theorems, which is, or not set of theorems, it's just this one, which says, is theorem 5.11, which says that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. This is also called the triangle inequality theorem. Write it. Which just says that two sides, when you add two sides together, they have to be bigger than the third side. Usually it's the shorter two sides. It's a good way to check. So for example, let's do examples 7 and 8. We need to tell if this is going to form a triangle with the given side lengths. So let's take a look. If I add these two sides together, are they going to be bigger than that one? Let's see. 2.1 plus 4.2 is equal to 6.3. Is that bigger than this side? No. So this will not be a triangle. Oh, if I could spell triangle. There we go. Okay, that's number 1. Number 7. Number 8. Now we've got fractions. It's easiest to always check with the shorter two sides compared to the longer side. So let's check with the shorter two sides. This is our one shorter side. This is our second shorter side. Let's add them together. 1 1/5 plus 3 3/4. I know it's fractions, so it's kind of weird. However, these are also decimals. So 1/5 in decimals is 1.2. And 3/4 in decimals is 3.75. So let's add those together. 1.2 plus 3.75. It's 4.95. So is 4.95 greater than 4.5? So 4.5 as a decimal is 4.5. So is that bigger than 4.5? Yes, so this will be a triangle. Okay, number 9 and 10. On these ones, we have to find the range for the measure of the third side of the triangle, given these other two measures. So let's take a look at these two measures. It only tells us two sides, so the third side could be smaller than these two, it could be in the middle, or it could be larger. So we just need to figure out which one will work. So if this is the larger side, let's assume that this one is the longest side of our triangle. We need our third measure to be, when added to 5, so when added to 5, plus our third measure, whatever that is, has to be bigger than 11. Is that bigger than? Straight up. So, if I subtract 5 from both sides, I treat this now like an algebra problem, I get x is greater than 7. Or, no, 6. 6. Now that's a strict inequality, which means it can't equal 6. It can't be 5 plus 6 equals 11. That's not going to work. That's not going to make a triangle. So it has to be strictly larger than 6. So this is part of our range. X greater than 6. Now, that is assuming that 11 is the largest side. What if 11 isn't the largest side? Then our numbers are just going to be larger than whatever those two are added together. 5 plus 11 greater than 26, which is already in this equality of, or this inequality of x greater than 6. So that's really it. That's all for that one. X bigger than 6. Okay, now let's do number 10. Okay, again, we're going to assume that this is our largest side to find the third side. So we'll do 2 1/3 plus our third measure, whatever that is, has to be bigger than 7 2/3. So if I subtract 2 1/3 from both sides, I get x is greater than 5 1/3. So it just has to be bigger than 5 1/3. Now, that means 6 will work, 7 will work, 8 will work, 9 will work. And once we get into those higher numbers, now x is becoming our largest side. So this is going to be our inequality. So x is bigger than 5 1/3. Okay, let's take a look at number 11. So this one says we just need to determine all the possible values of x. We'll probably do that by finding a good range of x's to that do work to do. So, for example, if I were to just pick x to be equal to 0 as just a tester, see how that goes. If I were to plug 0 into all of these, it would get rid of the x parts because 0 cancels things out. So this side length would be -1, this one would be 7, and this one would be 13. That does not work because we can't have a negative side length. So automatically, I know my x is going to be greater than 0. So if I start with that kind of thinking of x being larger than 0, that will help. Now, if x was 1, this side, xy, would be 4 minus 1, which is 3. This side would be 2 plus 7, which is 9. And this one would be 14. Now, which sides out of here are the longest? This side is my longest side. However, if that's my longest side, if x is 1, these two need to be greater than 14 when added together, and they are not. However, I can use this information to help me find a good range of x. This will be my largest side. So this side plus this side need to be bigger than this side. So I'm going to set that up as an inequality. 4 minus 1 plus 2x plus 7 has to be greater than x plus 13. Now I can just solve for x. I'm going to combine my x's. 4x plus 2x is 6x. Minus 1 plus 7 is 6 greater than x plus 13. I'm going to subtract this x over from the right to the left. So I'm going to have 5x plus 6 is greater than 13. And then subtract 6. 5x is greater than, what is that? 7. So when I divide by 5, I get x is greater than 7 over 5. And that'll be my range of values, possible values for x. Greater than 7 fifths. And I'm done. That's it for days 5 and 6, or 5.3 / 5.5, and we'll see you guys later. Bye!